This was in when I got in, and then I switched it to red. Somewhere in here, yeah, it turns into goes from white to pink to red.
Right.
So there's a little chip at the bottom of these drums
Yeah.
that it need to be in place before it'll start printing. And one of the drums, this is when we decided to tinker. One of the drums, the chip cracked, so it won't register. So when we buy a new one, we'll put that on this side.
There you go.
There's another type of plastic called ABS. Those are the only types of plastic that this particular printer will take. Just like
Thing right there.
you could write with lots of
Making
different kinds
that
of
be
ink.
red.
You could print with lots of different kinds of plastic, or even something that's not plastic, something that's glass, say. It really would very quickly cool and freeze. No, I'm here to answer questions.
Yeah, that was good that they have like chocolate. If room temperature is something relative, how can you breathe without
The chocolate down to something that is at a temperature where chocolate's definitely solid. So it would heat up, squirt down, cool really quickly, and then you'd have refrigerators and fans in place to keep it cool. But it would be trickier. The shape, I plug it in, or I program it on a computer or download it. There's a website called Alex mentioned, and our next step with this is that underneath you could put a heating element, because like you were saying, you want to get it down so it's nice and cool, so that it doesn't remelt. But if you cool it really quickly, it'll be kind of brittle, or it won't stick. It'll be too easily bent up. So sometimes if you have something that's very thin, it'll start to bend a little.
to be flexible, not flexible.
You can also, I think if you cool it a little slowly, instead of straight from, it's about 275 degrees Celsius coming out of the jet, and it goes down to room temperature, you'll get some very quick freezing with maybe some flaws in there. If you can cool it down slowly, you can make it look a lot better. They do that with jewelry. You can quench metal. With somebody in there, the computer can go at a much faster rate. And people use these lots of times for sort of changing specialty items. If you, for instance, really like lots of hobby cars, like that, people also use it for making models. If you want to make you build a car, you want to make sure it's going to make a 2010 model. Yeah. But I was likening this to printers in 1980. If you were printing out a 20-page paper, and also if you knew what you were doing, you could make your own printer. You wanted to go to an amusement park and print out your pass right there, and in 5 minutes. Everyone could have one of these in their house, and whenever they need to print something out, you just get it.
I'm doing a science center space program right now with the kids, and they mentioned that this is like something NASA's looking at. Seriously.
You have a piece of tubing that cracks in half.
Right.
You shove it into the machine, it remelts it, makes a new tubing for you, and you don't need any more mass. So
So that's, I thought that was very
all the cells you need, and then it puts them in the right spot to build up a kidney. So that one, you can imagine, takes a lot longer than 3 hours, and it's very, very expensive. I'll get from schools, people can email me just the file, and I'll print it out and then say, okay, so come by at the end of the month, and I'll have them all ready. And we'll just keep printing, because I can let this go and keep doing the rest of my work all day. Just make sure I don't hear any whistles or smoke alarms.
yeah.
So.
Parent sleeve. So if you are a parent and you'd like to get a tour of what we do here, I would be very happy to take you guys upstairs, show you around at least what the incubator looks like here at T-Rex if you have any questions. We're also a fashion incubator, so I can walk people by there if that's interesting. So If you were planning on staying so that you could listen to the presentation on 3D printing by Alex over here, he's actually going to be already presenting again on the 9th of October at Keating Theater at Kirkwood High School. So if anybody needs information about that, I am very happy to provide it. So if you're a parent, like we said, just go ahead and either gather up with me or kindly exit and plan on getting your kid back at 8:30. So anybody?
To the Academy of Science Teen Science Cafe, and my name is Jerry Zhang, and I am a youth leader. Youth leaders help make these programs happen. Before we get started, I would like to remind you of some ground rules. Out of respect for our speaker, I would like you to turn off your cell phones. Take a moment to get more food if you're hungry, because the table will be closed until we are done. Please don't just talk with your table. If you have a question, raise your hand so everyone can hear. And at the end, please stay until, because we have some closing announcements. Also, can you fill out the door prizes, because there will be a drawing at the end. Tonight's presentation is about 3D printing, the power to create. Our speaker is Alex Madinger. Alex Madinger graduated from the University of Missouri with a bachelor's degree in mechanical engineering in 2013. He started a business in 3D printing, leading him to a family with a boy named Ethan, who needed a new arm. Alex Madinger believed that the opportunities that mattered were those that moved forward as a species. So he created a hand for Ethan, and then stopped his startup to attempt to work in a bionics lab and go to grad school for biomedical engineering. Let's give Alex Madinger a warm welcome.
How you guys doing? Good. Can you hear me okay? Well, it's good to see some of you again from the practice run, and many new faces. And I have a general question to everyone to start off with. Who has actually used 3D printing before? Okay, great. But you've at least all heard of it. Has everyone heard of 3D printing? Has anyone not? Is this your first exposure to 3D printing? Awesome. Okay, you're going to see a lot of great stuff. Has anyone who hasn't used 3D printing wanted to? Well, then you're in the right place, because that's exactly what we're going to talk about today. So, to start off my story, it begins with a very important man, one of history's greatest men who we owe a great debt, James Bond. When I was growing up, I was always trying to make his gadgets, his spy gadgets, with hoverboards, grappling hook wristwatches. I was just drawing them on paper. I never actually made any of this stuff, but I always wanted to invent. I always wanted to be an inventor and create stuff. So I knew that from very early on. So when I got into high school, about your guys' age, I continued with that and started making props from video games and movies, and even some of my own stuff. So this continued, and I eventually learned that I should probably go into engineering for college, because engineers build stuff. So I went to Mizzou for mechanical engineering and met very many like-minded people there, like this guy. And once I was around these people, and they started to know what I was doing, they asked me, well, have you used 3D printing? That'd be great for you to make stuff with. And I looked at them dumbly and said, what's 3D printing? I hadn't heard of it up to that point. This was maybe 5 years ago. Shame on me for not hearing about it, but nevertheless, I hadn't. So to start this off, I'd rather show you versus tell you what 3D printing is. So just know that it's a way to make things. That's all you really need to know right now. It's a way to make things. And I've got a question for everyone. How many ways do you think we've used throughout all of history to make everything? Everything you've seen, everything you've touched, everything you've used. How many categories, how many basic ways of making things do you think we have? What do you think?
I would put that number into the thousands.
Thousands? We're going to go lower. Lower than 1,000. What do you think? Yep, no, you. I saw fingers going. Yeah. Yeah, 3. Great, wow. No one's guessed it that quick. So, throughout all of history, we've really just had 3 ways of making things. It's kind of hard to think that we've only had that limited amount of protein, but we've made those better. We've gotten to do cooler things, but in the end, we've been kind of limited in the way we can make stuff. So I'm going to take you back a long time to the dawn of man to start this story. Does anyone know what this picture's from? Who wasn't at the practice? Yeah. Not Planet of the Apes. Good guess, though. Yes.
Space Odyssey.
2001 Space Odyssey. If you haven't seen that movie, it is awesome. You gotta watch it. So, back when we were just men in monkey suits, we figured out that we could smash things to make sharp edges, to make arrowheads, to make cutting tools. That is way number 1. That's called subtractive manufacturing. And that is really no different than this. This is a modern version of smashing stuff together. This is called CNC, where you have a computerized drill that cuts a very useful shape out of a block. And we use this for nearly everything. This is a very common way stuff's made. My laptop frame was probably made that way. Let's see, what else? Parts for the outlet were probably made that way. I mean, anything you have metal where you need a certain shape, it's 1 out of 2 times probably made through this. It's very common, especially in cars and airplanes. That's way number 1. That's to the dawn of man. We've been doing stuff like that. Way number 2, I'm going to go back maybe 6,000 BC to fabrication. Taking components and putting them together to make something more useful, most commonly cloth. So that's way number 2. Again, that's 6,000 BC. Way number 3, you would think is maybe a little more modern because we've got a lot of awesome stuff. When do you think number 3 was invented? Do you think it was invented in the past 100 years? 1,000 years ago? What do you think? Past 100 years, it's going to be a little bit farther than that. I think it was before the Greeks? After the Greeks? What do you think? Yeah, the Egyptians. About 3000 BC. Came up with their 3rd way of making stuff. This is casting. This is obviously a modern process of that, but the Egyptians were casting stuff. They had figured out how to make things that way, to make amulets, to make more intricate shapes out of metal. That is formation. Those are the 3 main ways of making stuff. Subtractive, fabrication, and formation. And yes, thank you for raising your hand. If you have any questions, just raise your hand. Yes? How would the Egyptians be able to melt metal? Not a volcano. For those of you who've played Minecraft, you don't have to have a bucket of lava. You probably have to have a lot of fire. You just add fire together, eventually you'll melt metal. A little bit more difficult than the process they have here, but no, it was totally possible for them to do that. Yes?
Did they have like bellows or whatever to make the fire hotter yet, or?
I don't know if the Egyptians had bellows. Look that up. They were pretty crafty. I wouldn't be surprised if they did. But they most likely knew that fanning the fire would increase it. Yes? They may have melted copper. I know they melted gold. I'm not quite sure what metals they have in the River Delta. Man, I've never been asked any questions about the Egyptians before. I should learn more about that. I just know that they were the first to come up with this process. So let's see, what was cast? A lot of car parts again, airplane parts are cast. I think most watch parts are CNC. But a lot of statues you see, smaller ones that is cast or a similar process called plastic injection molding. So again, these all just go back to these 3 principles, except for 3D printing, or additive manufacturing, which was invented 30 years ago. It was just accidentally discovered 30 years ago this year. by a guy named Chuck Hull, who I think is on one of these tables. Anyone got Chuck Hull there? There he is. Hold Chuck Hull up for a little bit. See there. So this guy was working with a process called lithography, and I'm not exactly sure if this is true, but I want it to be true, so I'm going to at least offer you that this could be true. He was working with lithography, which is you have a liquid, and you shine a light on this liquid. And wherever you shine the light, it solidifies, becomes a solid. So if you have an intricate light pattern, you can make an intricate solid object. But again, it's flat. Well, he went off for a coffee break, came back, forgot he'd done it, did it again, and noticed that the layers had built up. Again, this is a fairy tale, I hope it's true. I would like to think he quit his job right away, started 3D Systems, which is the company that made that printer back there, and he's doing okay now. He's doing all right. So that's how 3D printing came about in the last 30 years. And again, this is a whole crazy idea. You may have heard people say this is the next industrial revolution, which may or may not be, but it's most certainly important because this is the first way we have of making stuff that's different than the Egyptians were doing. And I'll tell you, I'm making some pretty cool stuff, if you can see this. What do you think this is?
It's a lamp, and it has like a really intricate pattern, so when it shines through, it makes like tree patterns.
So you can basically turn your room into a forest. You can't make anything this intricate any other way. Even casting, you can't get all the intricacies. You have a question?
I was gonna say that was glass, you know how you use no glass.
Yep, nope, this is plastic. This is most likely nylon. So you have, that is one example of stuff you can make with 3D printing. You can make instruments. I got to listen to a band play these 3D printed instruments. You can make shoes. These shoes are inspired by the exoskeleton of sea animals. You can, this is by special request from a past presentation. You can print fingernails. You can print glue-on fingernails. This is one of my favorites. That's bacon. That's bacon. That is bacon. That one's plastic bacon. But we are printing with meat. Yes. A company called Modern Meadows, which started over 2 hours west of here in Columbia, is printing with meat. And a company closely tied to them is printing with human cells to make organs. Print organs out of your cells for you. It's basically yours. They're making really simple stuff right now, but they are hoping to have some liver tissue by the end of the year. So, yes?
Doesn't that mean that
The question is if you can clone someone using 3D printing. You know what? We're going to take a quick poll. From what I've told you so far, who thinks you could? Who thinks you can't? We don't know yet, but you could probably clone through other means, through more genetic means, because, I mean, nature's got a pretty good way of making people, as you can see by the room. There may not be a need to use a 3D printer to make a person, if we would even want to. We have to contemplate the ethical issues with that, which we're going to try and keep it to an hour. We better avoid that question. But we can make parts of people. We can make blood vessels right now. We can make parts to help nerves grow back together. That's already been done. And we're moving up to actually make replacement organs. So no longer need a donor. You can have one made from your cells for you. But most importantly, we can print with meat and with bacon. Yes. And there's something special about this bacon. Why is this bacon shaped this way? Yes, you look like you know.
it's a Mobius strip?
What's a Mobius strip?
It's when a, I guess, three-dimensional circle,
Uh-huh.
I know that doesn't technically exist, but it's the best way I can articulate it, has a half twist in it.
Uh-huh.
So if you were to run your finger along one side of it,
Okay.
it would eventually come back to your starting point.
So it has an infinite surface area,
No.
but let's pretend it did. And it has,
Then you would have an infinite amount of bacon.
Yes, yes, gold star. You get an extra piece of pizza afterwards. We can print a Mobius strip, which technically has one side. If you run your finger around the outside, it'll eventually come back in and back out. So we technically have infinite bacon. That's one of my favorite applications. So, and you could print this in meat, so you can eat infinite bacon. Awesome. You could print you, to your question from earlier. This is a little less complicated than you are. This is just a bust. It's just a model. But, oh, you had a question? Would assembling something be considered fabrication? In many cases, yes. How big can you 3D print something? There are small buildings being printed in concrete. Some of them are emergency structures that they can just set the robot up and walk away to do more important things in the emergency and come back and have 5 houses built. A guy just 3D printed a concrete castle in his backyard. And really cool, we have experimented with printing with materials from the moon. Materials you can find on the moon. So who's going to tell me why that is awesome? If we can print with stuff from the moon, what does that mean?
We're going to start printing stuff from here on Earth and transport it somewhere else.
Well, if we can gather the build materials on the moon, and we send a robot up to the moon with a 3D printer on it and can collect that stuff, yeah, we can design the houses here on Earth, email them to the robot, and it'll build them there. Yes?
So when we wake up at night, we see a castle.
Yes, I mean, you feel wherever you can daisy chain satellites in the process I'm not going to pretend to understand to get the signal to wherever you want. You probably just aim it. I don't even know if you need the towers, but yeah, you could essentially design it anywhere. It doesn't have to be Earth. What's the question? Do you have to be on Earth or can you be in space? And sure, you can get the email there. And on that note, NASA just sent a 3D printer up to space, I think just a couple weeks ago. Because 3D printers are awesome. The question is why they put a 3D printer in space. Because 3D printing is awesome. And to experiment with how it works in zero gravity, as well as the hope of eventually having them in space for the use of creating replacement parts. Something breaks, you could use this to make replacement parts. Okay, we're going to take one more question before we move along.
Okay,
Yes.
so when you're about to 3D print something, how do you get the design, how do you tell the computer what the design is?
I will show you. I will show you. So that was a half question, so I know you have one. What was this question?
Yeah, the organs that
Yes.
3D printer makes, has it been proven that they are supposed to work the way regular organs work?
Yes, they take some cells. I'm sorry, I got to repeat the question. The question was, have they been tested to work, the organs that have been printed? They will take a bunch of cells, make more cells from that, and use that as the build material to selectively place them down in the process I'm going to show you. And then the cells do the rest, and they grow into the geometry that it was put down in. And then they exercise it. They put this blood vessel into a system where it was pumping blood, and it was working. Okay, so you could print a U is one of my other favorite examples because people are actually taking full body scans and printing little pieces of themselves to use in board games. So if you play Monopoly and forget the top hat, you can actually have a little mini U going around the board. So you know how document scanners work, right? You put a document into the scanner, it shoots a bunch of light onto it, and it shines a bunch of light onto it. Shoots a bunch of light onto it. Whatever reflects back, it'll make a digital copy. You're taking something physical and making it digital. It's kind of the reverse of writing something up in a word processor and sending it to a document printer to get a piece of paper out, right? So that's kind of a good analogy here we're going to get back to, and that's kind of why people have called it 3D printing. But just like you have a document scanner, you can scan physical objects. You can scan you to create a digital model to print from. So you could easily do this. This is a picture I took in London. This is a structural piece. This is that. These beams, these are keeping the room from falling down. So these are great. However, as you can see, these are really boring. These are just basically cubes, basically rectangles. I mean, no special geometry. We've over-engineered them to make sure they hold up, which is great, but we've kept them very simple. We've been keeping everything really simple. That's a trend you're going to see. This is complicated and beautiful and feathered. This, they analyze the room, see where the weight's going to be. It's going to be here and here, but not there. And they say, okay, if that's the case, we can remove material from there. We don't need so much there, but we should add some here. You do that again and again and again and again until you come up with the optimized structure that only has material where it's needed, so you're not wasting. And it ends up looking like tree roots, which is really cool because it's like nature's had it right all along, and we're just now being able to catch up and make stuff in that shape. Yes?
Did they account for like earthquakes in the region?
Yes, that's called a factor of safety. So you do all the work, and then you multiply it by like 1.2 or 1.5 just to make up for any unexpected earthquakes or surprises or really heavy birds, angry birds. Let's see. This is the second to last one. Who can guess what this is? What do you think it is? Yes, this is a fake skull. That is from someone's CT scan. They took a CT scan of their skull and then printed a copy. What do you think the metal part is? What do you think it is? Yeah. So this man was in an accident and had to have part of his skull removed. And they were able to, from that scan of the skull, take the other side, mirror the geometry, and be able to make a near perfect fit just for him. A unique, very complicated in detail. Not that this is really a complicated detail, but it's complicated because it's unique to just him. This is his shape, and it fit perfectly. That's titanium, by the way. We can print in not only plastics, but metal as well. But on the topic of metal, I'm going to say my favorite metal is probably iron. I'll let you guess why in a second, because the next picture is my all-time favorite application of 3D printing. Iron Man was 3D printed. For the movies, they 3D printed the suit for Robert Downey Jr. And I know this because I got to meet one of the guys who designed it, and he did let me put on the gauntlet from the movie. So that, you know, even though I'm seeing all these awesome 3D printing things, this was honestly one of the coolest parts of the trip. So all that being said, we started earlier by just saying 3D printing is a way to make stuff. And now you've gotten an idea of what it can make. And it looks a little different than the things you've normally seen, right? It looks a little more natural. It looks a little more flowy with a lot more detail to it. That's the idea. 3D printing's mantra, its rule, is high detail, low volume. 3D printing is good for highly complex and or unique objects. So a complex object like that lamp we saw earlier, or a unique object just to you, like that skull plate, in low volume. We only got to make one or a handful of them versus 10,000. And that high detail, low volume of 3D printing is the exact opposite of the way we've been making things forever. If you wanted to make a toothbrush, you would have a bunch of engineers design it so it's very simple, and then they would make millions of them, all the same. And they would have to make it simple, so one, it worked, and two, because if they messed up, there's trouble, because they have to say, okay, this is right, pay someone $10,000, $30,000 to make the tooling, tool the cast for it, when you use CNC, most likely, that part earlier you saw with the drill, that can be very expensive to make it just right. And then they have to have that right because they have $30,000 to make up. So they have to sell 1 million of them. And that's how you get a toothbrush to cost 10 cents, is by making a lot of them. If you just wanted to make one bracelet with that process, it can be very expensive. That's why this is better for low volume runs. It only costs as much as the material you make. It's actually cheaper to print the most beautiful, intricate statue you have ever seen than the bounding box, the box that it would go in if you were to print it solid. Because there's more material being used in that box than the statue that would be within it. So that's what 3D printing is good for. It's only good for a handful, not a handful, it's only good for some things. It's not good for everything. We're not going to replace everything with this. But it's really cool because now we have a fourth way of making stuff. And that opens a whole new arena of things we have not been able to make before, or haven't even thought about making because we dismissed them because it wouldn't work with the tools we have. All of a sudden, we have a whole new playing field here, and it's going to get really cool. So 3D printing is different because instead of taking a block and cutting away, it's the opposite. It's additive. It only puts down what it needs. You'll start with a digital model. Have you seen Toy Story?
Yeah.
Okay, good. I'm not that old then. So, you know all the digital models in Toy Story, right? That is enough to 3D print the character. That works. I'm sure some of you play video games. The models in video games are enough to 3D print. 99 out of 100 times. You need a digital, three-dimensional model. A picture won't work. A picture's 2D. So if you do stuff in Photoshop, that's all 2D. But if you make a 3D model, like in Toy Story or video games, stuff like that, besides Paper Mario, that is what you need. That is how you tell the printer what to do. Printers are dumb. They're like computers. Computers are dumb now. My favorite quote is about computers is, darn these computers, they only do what I say, not what I want. So do you got a question?
Yes. How can you get a three-dimensional model? I guess three-dimensional to know how to put it on a three-dimensional screen.
How can you make a three-dimensional object on a two-dimensional surface?
Yes.
All right, take it the two-dimensional surface is your screen. You have the ability to rotate. So just like I'm looking from one perspective right now at this column, I can take my perspective, the camera I'm viewing this with my eyes, and move it to see the other side. That's what you can do on a computer. You can drag the mouse around and change your perspective, change the camera to look around the object. So while you're only looking at a 2D representation at one time, the 3D object is defined. Does that work? Cool. Yes? Huh?
Okay, so there's this new app coming out, and it's like basically take like a bunch of pictures and like get a 3D idea of it.
Yep.
And I think this is basically for 3D printing, so you can upload it and stuff.
Yeah, I'm going to use that to make this later. This is from the front desk. They said if I made a copy, I could keep this one and give them the copy. So, yes, there is an app. One of them I know of is called 123D Catch.
Yeah, that's what it's called.
Yep, I've used it before. I made a gnome army with that one. I had a garden gnome, and I was able to use that to get the model of it, and I printed a small army of them. They weren't very good at fighting. So that's the gist of how 3D printing works. You start with a digital model, you send that to some software that says, okay, I got a loaf of bread, but I can't just make a loaf of bread. I got to take this one slice at a time. So I'm going to say, okay, here's the first slice, here's the second slice, here's the third slice, and as many as you need to make the loaf of bread, which each of those heights being a certain height, each of those layers being a certain height. Another way to think about it is a step pyramid. So if you were to build a step pyramid, how would you do it?
You would make one layer first, and then you put a layer on top of it.
Yep, you make one layer first, and then make another layer on top of that, another one on top of that, kind of like this, right? That looks pretty bad. We want a more detailed object. So what we're going to do is make the layers thinner and add more of them. And we're going to keep doing that until you can barely tell they're there. That's 3D printing. It just starts at the bottom, puts one layer down, raises up, puts the next layer down, raises up again, and it does that on such a fine level, most of the time you can't even tell there are layers. What do you think the average layer height of 3D printing across the different types of printers What do you think? Actually, you were really good at guessing earlier. Okay, so we're up again. We're going to go in microns, which is a thousandth of a millimeter. 1 micron is a thousandth of a millimeter. How many do you think here? 5 is better than we can do, so a little bit more than that. We can't do 5 microns yet. 100, that's right. So again, a micron is a thousandth of a millimeter. A millimeter is like that big. 100 microns is the width of one of your hairs. And like half of you and just touched your hair. So we can print pretty much all the time at a level as fine as the human hair. We can go down to 16. 16 microns is the best we can do right now. Some say 14, but the professional consensus is 16 microns. So again, we're printing at such a fine level, you can barely tell the layers are there. But all this object is a bunch of layers stuck together. So now that we've talked about it a little bit, I want to show my favorite video of 3D printing being done and what people think of it and why it's important.
As humans, we always strive to create, to build something that will solve a problem or meet one of our needs.
How would you feel if you could hold some of your designs in your hand and it went like that? That's impossible. I said, well, let's assume it's possible.
I'm not a designer, but now that I'm seeing the possibilities of this technology, you start to see the world differently and you start to reimagine the objects around you.
People are taking the power of creation into their own hands.
Boom, open up your little skull, pull out your idea and create it. Like that's what Shapeways does in a nutshell.
3D printing is a way of making things element by element additively. The things that we're designing, you can't make any other way.
I can make objects bigger, smaller, stranger. There's no limit to the variation you can apply.
And I suddenly realized how much I was restrained by a lot of the technologies that were around before.
When something new comes to this home, she asks, have you bought it or have you made it?
And if you look around us, we can buy any product we need to do whatever we want. What's missing, however, is our personal input into those products.
You have an idea, and then in the mail, the idea comes sort of as an object, and like, that's never existed before.
As a designer, you can concentrate on making the best object, the best product you can, and Shapeways does the rest.
So we can make one of something and test it out. And all of this doesn't make any difference because there's no tooling, there's no molding.
There's no investment for a designer. It means also you can innovate faster. There's no penalty for innovation.
This gives rise to a whole new way of solving problems.
It's mind-blowing to think that we can build something today that was literally impossible yesterday.
So that is Shapeways. They are a 3D printing service provider in New York. They are one of a handful of companies who have bought an industrial printer, or a number of industrial printers in their case, and they will print stuff for you. You don't have to own the printer. If you make the design and you make it here, you email it to them in New York. They will print it there and physically ship it back to you when it's finished. You can do that really anywhere. You could design something here, ship to China, vice versa. You could have someone collaborate from anywhere in the world and have it really made anywhere there's a printer. This is the whole tearing down the wall between the physical and the digital. Digitally, we're able to share information very, very quickly, and now that can, in some way, translate into sharing objects. So, you want to try it? You want to make something here and email it to New York and have them make it for you for free? Very good. So now is the fun part where we get out the computers, and we are going to make some bracelets for free, thanks to Google and Shapeways. So here are the instructions. To get online, go to T-Rex Guest. You shouldn't have a password. And did someone have a question over here?
Oh, I was asking.
Well, you know what? After we do it, remind me to talk about the what these would probably cost you about $5 to make, but they're going to be free. Here is the URL, madewithcode.com, and all the instructions you have to follow. But basically what you're going to do is you're going to be presented with puzzle pieces you have to fit together. That will create the digital model, and then you'll be able to customize some aspects of it, like the name on it, the color, and then ship it off. And if you don't have a computer, this is mobile compatible, so you can use your smartphone to do this. And again, the Wi-Fi is the correct guess, and there should not be a password. If anyone has trouble, just raise your hand and I'll... All right. What's up?
Change correcting, right? I have one of these, just like messed up. But like if you were to
T-Rex guess. You guys got it? Anyone having troubles?
All right, let me see.
What's up? Okay. So here's your first puzzle piece. Yep, take that and drag that to the outline there. You got it. And then you'll see those triangles there. Those will fit into that. So drag that over. You got it. Nice. And then those are your last ones. And you'll be able to change, once you put them in, you'll be able to change the dimensions and the color. Yep, you got it. How you doing? Got it?
I did.
It doesn't matter which one you
If it doesn't work, I'll be right back. Who's having trouble?
Hey, has everyone made one?
That's really to check the rest
Yo, people, oh, you got a question? Okay. Is this your computer? Why don't you take this home to your parents and they'll help put the address in. Does that work? Okay, you already did the fun part. So. Hey, you got a problem with the address? Oh, yeah. Yeah, sure did. Okay, we're ready. So, who can tell me what you just did? What did you just do? Which is, yes. Yeah, that's exactly right. Made a 3D model. That's what dragging those puzzle pieces together was. That created the 3D representation on the back end. You were just controlling the different parameters of it. But you didn't actually get to see it until the end, when you got to see it in color with your name on it. So it created a three-dimensional model, kind of like the Toy Story characters. It emailed that to New York, and they have it now ready to put into their printers. And the printers will slice it up digitally, know where to put that stuff down, and make them and have them to you in about a month or so. So what is cool about this process? Did any of you, do you think, make the same bracelet? Do you think you made the same bracelet as anyone else in this room? I don't know in color, but the message on it. So you each had a unique bracelet, easily. That is why 3D printing is important in this case. To make it the old-fashioned way, with one of those three processes we had before, you would have to either make a different mold for every different name or make them by hand. You couldn't do this nice, quick process where the computer takes little changes in the design and it's fine with that. It just matters what the shape is. It doesn't care what it is, as long as it can read the shape. That's it. That's why 3D printing is important for things like this, and you have now all made your first 3D printed model, so give yourselves a round of applause. Can I ask you a question about the, is that your computer? Do you mind taking it home and asking your parents to get the shipping to work? Okay, cool. And if anyone had problems with shipping and it's your computer, your parents will be able to help you out with it. So well done on making your first model. And who wants to make more? This was just the gateway. This was just the start. You've gotten a taste. But it's not all like that. It's not all just plug in your numbers and it'll be made. Some of it is, but a lot of it's up to you. A lot of it's what you're going to create. And that's the cool part. Nearly anything you can create on a computer, nearly, not everything, but nearly, you can't make everything. You can't make a solution to Windows 8. No one can make it. So it's up to you. If you have the ability to make these models, send it to a 3D printer, and you've got nearly any object. So I'm going to show you how. You need two things. That's it. Two things. Access to the printer and the ability to manipulate the models. Number one, you've already done it. You just did it. You just emailed to New York. You don't have to own the printer. You know there are companies like this who will take your models and print them for you. Yes? Are there any that would do it for free? Unless it's a program like this, or you know them, or there's some kind of educational program where if you say you're a student and you're printing this for school, I don't know of any going on right now, but I've seen some of those in the past. In those cases, they'd be free, but these are companies, these are businesses, and that's how they make money. And you were supposed to remind me about cost. Cost, thank you. So, I told you how much that bracelet would cost, right? $5. How much do you think, just think this would cost? First off, who knows what this is? It's an ear cube. It's a very important object. It has a very special function. It's fun to play with. That's all it is. I don't know who made this. I just downloaded this, but I'll show you later. This probably cost, I used to know, 20 bucks? No, less than that. Maybe like 10 bucks. 10, 20 bucks. This is really intriguing. Oh, okay. It gets expensive quickly. She said this is really cheap. How much would it cost to print one twice as big as this, do you think? If this costs $10 to make, how big would it cost twice as big? What do you think?
Twice as much?
Twice as much? No. No, that's the weird thing. It's not twice as much. It's cubic. It's all volumetric. Go back to that statue example. It's all about how much material you use. And we're talking about a volume. So if you double the length, height, and width, you've done 2 times 2 times 2. 2 to the third, which is 8 times as much. So if we want to do 3 times as big, 3 times 3 times 3, 27 times as much. So if you wanted to print one 3 times as big, it would cost $270 and take 27 times as long to make. And this took 8 hours to make. And if I wanted to calculate how long that'd be, I'd tell you, but it's going to be long enough. 9 days. 9 days. I hope I'm right. So that's an idea about the cost of 3D printing. If you're making small stuff with inexpensive material, you can make a lot of cool things for not much. But if you're building giant things, you better be using concrete, or it's going to get expensive quickly. So there's a number of these service providers. There are more of them. This is the magic Google search word, 3D printing service providers. I've used half of them. They're all great. And yeah, they're relatively inexpensive if you just want to make 1 or 2 things. Again, high detail, low volume. If you're just making a couple, it doesn't cost very much. But if I wanted to make 10,000 of these, I wouldn't get a benefit for making more. Normally, the more of something you make, the lower each one costs, because you're splitting the price of that original really expensive mold. But each of these, the first one's going to cost as much as the last, $10. That doesn't get to change. That's why you only want to make a few. If you want to make millions of something, you better use one of the old ways. Unless really, really complicated and you couldn't. Then you got to afford the cost. So you can check those out. You can print with many different materials through these companies and many different ways of printing. There's 7 total. I'm not going to go into all of them. I'm going to give you the most common 5. There is many different ways to go about this. Some use glue, some use lasers, some are kind of like a hot glue gun. Each have different strengths and weaknesses and different materials they use and different costs. So this is what you want to look for. It's not like just give me a 3D printed object and you get this. You could have one that looks like this instead. They're both white, sure, but this one you can feel the ridges on, and I can drop this all I want. This one, I can't even tell. This is the 16 micron one. This is the best 3D printing we can do, and I do not want to drop this because it will break. So that's something you just want to be aware of. There's many different ways to go about this. This is actually called 3D printing. Forget that. That's the company. There should be a dash. And they're sold to that company now, actually. Or they're sold to Stratasys. They're sold to one of the companies. This uses chalk. This was created at MIT. They created it back in '89, patented in '93. So, were some of you even born in '93? This is older than you. Cool. This is good for making like the models of like that guy's head. If you want to make things in a lot of colors, this is the way to do it. However, these are going to be really brittle models, so you wouldn't want to actually do anything with them. These are just stuff you want to look at. That's binder jetting or 3D printing. It'll say sandstone on most of the sites. Next one, you recognize that guy, is fused deposition modeling. That's the type of printing going on right there. This uses a couple of plastics. That one's using something called PLA, which is made from corn. This one's made from ABS. What else is really popular and made from ABS, do you think? This plastic. I bet all of you have used this toy before. What do you think?
Legos.
Legos. This is made of the exact same stuff Legos are made out of. So in theory, you could shred Legos up into this plastic and make the Lego again and just keep doing the cycle. So this is a really, really common type of printing. If you're going to have a home printer, not a professional one, it's most likely going to be this. One, because it's got relatively simple machinery. Two, the patent's expired. So everyone's making these now. So this is a medium cost printing, lower end, really common. You're probably going to end up doing this. Stereolithography is the type of printing the guy accidentally discovered back in the day. This is the first type of printing. Really, really nice surface, really nice detail, really brittle. They're getting a little more expensive here. But they do sell home versions of these. Again, invented at MIT. Well, that one wasn't, but the home versions were invented at MIT. This is the process that made Iron Man. This is the 16 micron detailed one. This is the one that made this. Super nice detail. You can barely tell it's 3D printed. It's really cool because you can actually mix materials with this one. So you can have a whole range of different material properties. So you can mix a rubber-like material with a stiff material to actually create something in between and do that all over the model. So this one is pretty much the best 3D printing we have. Yes?
How much is a 3D printer cost?
I will answer that in 2 slides. Sure. She asked how much does a 3D printer cost? Last one I'm going to tell you about is the one with lasers. This one has a bed of plastic beads, and it uses a laser to sinter, almost melt, the ones it wants together. And then it brushes more beads on top and does it again. And you end up with this giant cube of powder. Remember in the video earlier when they had that giant cube of powder come up? That was this. And you have to like dig through it to find your objects and then clean it off. Really strong, but a little more expensive. Or you can buy one and have it yourself, or make it yourself. This is called a rep wrap. You can make one for $500. That one maybe costs $2,000, maybe a little bit more. It's pretty big. That might cost $3,000. It's probably under $5,000. That's a MakerBot. That one costs $2,000. They are one of the top of the line consumer 3D printers now, but they're going to range you $5,000 to $2,000 to have one yourself, which is a lot if you're not making a lot of things. I would promote you go through the service providers first just to get started. But those are all home 3D printers. Guess how much the big ones cost? What do you think the most expensive printer costs? Much more than $100,000. That is the average cost for professional printers. Actually, might be a little under average. More than $100,000. Under $2 million? Yes?
1 million.
1 million. It is a French 3D printer called Phoenix. It uses metal, and its surface finish is so fine you can not tell it's 3D printed, and that's saying something for metal 3D printing. So it ranges from $500 to $1 million, and that's just the cost of the printer. You still have the cost of the material to make things. So that's tier 1. You have access to printers. Don't think you don't, because there are these companies who are willing to make stuff for you, and they are within reason to buy if you find yourself doing it a lot, or your school, wink wink, wants to have some kind of 3D printing lab set up. It is there accessible by all means. Number 2, this is the important one, is how to manipulate the models, like you guys just did with the bracelets. There's 3 ways of doing it. The number 2 up top, you can do right now without learning anything. Number 1, or 0 I should say, is just downloading. I did not make this. This is a very popular model online. I don't know who made it. I don't know where he made it. I just went to this website, Thingiverse, where a bunch of people put these online for people to download. And I downloaded and made it. And here it is. People have changed this up a little bit and put those online to download. So if you think about making something, just go to one of these sites and see if someone else has made it. Maybe you can work with them to make it better, or just, there you go, you've got it made. Number 2 is what you guys did, I should say half, is what you guys did with the bracelets. Someone did all the modeling, and then they made an interface with you to control some of the aspects of it. You could change the name, you could change the color, but you didn't actually make the model yourself. This is called co-design. You can make things taller, wider, twist them, make different shapes for like cups and things like you saw in the video. Shapeways has some options to do this, or at least some of the service providers have ways to do this. So again, ways for you to customize without having to model it yourself. But if you really want to get into it, if you really want to make your own stuff and use the full power of 3D printing, CAD, computer aided design. You got it. This is how you make models. There are hundreds of these programs. Many of them are free. Many of them are free because you're students. These are relatively easy to learn thanks to all the tutorials that are online. Go onto YouTube, type in the name of it, tutorial. I mean, I was able to learn a new one in a week thanks to YouTube and Vimeo. I now know how to do 3 of these, and they each have different properties which are better at certain things than others. Like there's some are good at engineering stuff, there's some are good at making models like Toy Story. It all depends what you want. If you're interested in learning CAD, these 3, at least I know the top 3, you can download for free. I'm pretty sure these 2 you can download for free if you're a student. Is SketchUp, SolidWorks, Rhino, and Maya. SketchUp used to be made by Google. It's really good at making buildings and architecture because they're really smart and wanted to populate Google Earth. So they said, let's give this CAD out for free and have people make buildings for our Google Earth. And once they had Google Earth pretty much populated, they sold it to a company and made even more money, which is awesome because Google can do awesome things and make money. So SketchUp is still available for free, tons of tutorials, really easy to get into. If you haven't done anything like this before, I'd recommend starting with that. If you have done something like this before and you want to get into more engineering stuff, SolidWorks you can download. I know you can download it with a college email. Do you guys have student emails for high school?
Yeah.
If you have that, give it a try. It will probably work. If not, SketchUp will definitely work. You can be anyone and download that. Rhino you can try free for 3 months. It's kind of in between SketchUp and SolidWorks. Who programs? Who's a coder? Rhino works with Python and is awesome because of that. It's awesome on its own, but it's really awesome because you can tie in code to your models. You got a question?
Which one is SketchUp?
SketchUp's the SketchUp, SolidWorks, Rhino, Maya. Maya is good for making more natural objects like the Toy Story characters. Has everyone got them written down if you want them? Okay. So, I want to leave you with a thought, 2 stories, and a question to kind of wrap all this up. Does anyone here actually consider themselves an inventor? Okay. Has anyone encountered a problem before? If you don't raise your hand, there's something awesome about you. You've never run into a problem before. So if you run into a problem before, I want to challenge you to change your mindset when you come to that problem. Instead of thinking, this is terrible, someone should do something about this, or nothing can be done about this. Instead, consider it as if you could do something. If you could change it, what would you do? Can a physical object change this? If so, could you make it? And you may be the one to solve the problem. Seth Godin is an entrepreneur, a very successful entrepreneur who teaches entrepreneurship. And he has an awesome message, which I think is very important for everyone to hear. No one will ever give you initiative. You will have to take it from yourself, for yourself. A parent won't give it to you, a teacher, a mentor. No one will give you initiative or require you, or they can require you in a job, but that's more just a job, not true initiative. True initiative comes from you. It comes from you wanting to solve the problem or to make something better. If you have that desire, maybe 3D printing is the tool to make it. That's what I did with a family in Jefferson City. They have a little boy named Ethan, who's 6 years old now. He was 5 at the time. Born without most of his right hand. And they approached a friend and me and said, can you 3D print our son a hand? We've seen these designs online. We just need someone to make it. We said, yes, of course. This sounds awesome. So we took the design, we learned about it, we scaled it just to his size, and guess what? Did it work? No, of course not. It took 3 more tries to make it work because he was such a special case that that design wouldn't work for him. You have to have some risk move the hand, and he didn't have enough wrist. But we didn't stop there. We saw the problem, we tried a solution, didn't work, but we took it upon ourselves to try and make it better. So using our modeling skills, both computer and good looks, we